A man is driving car at constant speed of 10 meter per second. He has reaction time of 0.2 seconds. He sees end of the cliff when at a distance of 100 meters and then applies the brake. If retardation of the applying brake is 1 meter per second square, will the man be safe? So let me explain the question with a diagram. I forgot to mark the key things. Now, we are looking at a cliff. So it's say foggy. It's a foggy day and you have the person in the car. He is already in motion with a speed of 10 meter per second. And he happens to notice the cliff, which is 100 meter away, and he applies the brake. Okay, so then where is it? The brake puts a deceleration of 1 meter per second square if I take right as positive direction. So since deceleration, it should stop the vehicle over here. It is negative. So 1 meter per second square. So he does it after 0.2 seconds. So he sees at this moment of time, after 0.2 seconds, he is able to apply the brake. So will he be safe is the question. Okay, I hope you guys have tried it. I have not told this, but by default, every time I take a pause, it's for you guys to pause and think actually. Right? Now, so let's figure out how will we do this. We know that the object has to come to a stop on the applying brakes. Well, let's assume that the object will stop over here itself, wherein the final velocity is 0 meter per second. That's a stop, is it not? So let's see how much distance the object needs to come to a stop. So this can be the formula. So let's start with the distance needed for the object to come to a stop. We can calculate with the help of this. So this is 0 square, u is 10 square plus, so this is minus 2 into s. So this is 50 meters. But he has a reaction time of, we need to also consider that the reaction time. That is, after seeing, he takes 0.2 seconds to apply the brakes. So during reaction time, the distance. So I hope you guys are understanding in what direction I'm going with the distance the car would have traveled will be, yeah, this I can use s is equal to ut plus half at square, or just s is equal to ut, because there's no acceleration, there's no deceleration over here. So 10 into 0.2, that is 2 meters. So all in all, we have total distance covered is s is equal to 52 meters, which is less than 100 meters. Thus the person is safe. So as simple as that. What if the speed was 50 meter per second? Okay. If u is equal to 50 meter per second, then SR, we can call it as SR, that is the distance traveled during the reaction time. We can call this, it's much convenient. and post brakes, SP. Okay, during the reaction time, 50 into 0.2, that is 10 meters is what you would have covered. Then after braking, right, is what we are trying to figure out. For that, we can use V square is 0, U square is 50 square minus 2 into SB, that is post brake, how much the person will travel, 2500 by 2. So this itself is much greater than 100 meters. So yeah, it's too fast for the person to stop. So basically this is much greater than this implies the person will, the car will jump off the, what is the thing question? Will the man be safe? The man will not be safe. I'll just write that. Man is not safe. Again, it might feel weird that we are writing that, but that's the question. His speed was 100 meter per second. What should be the deceleration to stop on the edge? So we need to find out deceleration. Okay, so first thing is, let's see the distance traveled during reaction time. So this is 100. So he's already traveled 20 meters. Now, post deceleration, so we have 100 square plus 2 into A is what we need to figure out, and this is 100 minus 20. Because he's already covered 20, so remaining distance is 80. So within 80, we need to figure out what should be deceleration so that he's safe. So this would be 0000 by 2 into 80. So 1010. So 1000 by 16. Actually, you should know what is 1 by 16 by heart. So this is 6.25. This is there's a negative meter per second square. So the deceleration should be 62.5 for the person to be safe. A bit more than that is what is needed. Is needed to stop at the edge.